Welcome to Bahamian Mathematics. In today's video, we will be working out some past paper questions. And today's video is on BJC Paper 2, 1988, question number 16, which deals with geometry. Let's take a look at that question. The question starts off with a diagram like this, which is a combination of shapes. And it asks, from the diagram above, write down a pair of parallel lines. Now we have to know what parallel lines mean. And we know that parallel lines are two lines that go in the same direction, the equal distance apart, and they never touch. And when we look at the diagram, we see various lines going in different directions. And we may be tempted to say, well, this line and this line look like they could be parallel. They look like they are equal distance apart and they don't touch. But if we drew a line down, and we drew a line down there, we can see that the lines start to separate, which means if we go in the opposite direction, they will start to close and eventually they will cross. So they are not the same distance apart. If we look at these two lines, what helps us is these two arrows, which mean that they are parallel. And so this line and this line are parallel to each other. And that line on the top is called AB, and the line on the bottom is called DC. So this is a pair. A pair means two of parallel lines. We have AB and DC. Now, what happens if someone says, well, this is a line as well, and that looks parallel to AB? You would be right as well. And so we have to name that EC, and so the pair is now AB and EC. Here's part 2. The question asks for a pair of perpendicular lines this time. What are perpendicular lines? They are lines that cross at 90 degrees. And so we have defined in the diagram the lines that cross at 90 degrees. And so here's a line, and here's another line. We can see in the corner there is a small square which represents 90 degrees. So these two lines are perpendicular. So we name them AB and AD. And again, you may say, well, what about this line at the bottom and the line right here? Don't they intersect at 90 degrees? And you would be right as well. And so there are multiple answers to these questions. This line is DC, and this line is AD. And so DC and AD are also perpendicular. And you may say, well, what about this line, EC? Isn't that perpendicular to AD? And you would be right again. And so another answer could be EC and AD. Those two, that pair is perpendicular. The last part of the question gives us another diagram. And it asks, from the diagram above, calculate the size of the angle marked 2x. Now, when you look at the diagram, you should be able to see that this is a question that shows a straight line with various angles on the straight line. And we know that a straight line has 180 degrees, no matter if it is divided into 2, 3, 4, however many angles. They all should add up to 180 degrees. And so we know the general formula is A plus B plus C equals 180. When we add up all of the angles, they are supposed to equal 180. And this shape right here we know is 90 degrees. It's a right angle. And so we will start to list all of the angles that we see. Even though I don't see any numbers in degrees, there are algebraic terms there, 2x and x. And so we just need to add up everything and make it equal to 180. And see what we have in our equation. So let's start with 90 plus, I see 2x plus x equals 180 degrees. 2x represents an amount of degrees. The angle x also represents a number of degrees. We don't know what they are yet, but we will find out at the end of this question. And so what we do now is we combine like terms. And so 2x plus x is 3x. All of that equals 180. Now we're going to put the numbers on one side and the terms with letters, we're going to keep them on the left-hand side. So the 90 that's on the left has to go over the equal sign to become subtraction. And so 3x equals 180. Take away 90. Now this is starting to come together. 3x equals 180 minus 90 is 90. And we're almost there. We know that 3x equals 90. But what is x? X is equal to 90 divided by 3. And we know 90 divided by 3 is 30. So x is 30 degrees. But the question didn't ask us what x is, it asked us what 2x is. So if x is 30, 2x is 30 times 2, which is equal to 60 degrees. And we found the solution to our question. If you want to see more videos and worked past paper questions like this, check out Bahamian Mathematics. Subscribe, like, and share to see more videos just like this one.